everyone, welcome to Learn at Leisure. In this video, I'm gonna teach you the complete data science process. So without any further ado, let's get started. The first step in data science process is to set the research goal. As we all know, without goal there is no purpose, right? So first of all, the data scientists set a goal, okay, which is known to each and every team member. And this is a very important step as it gives the clarity on what they need to do, where they need to concentrate, and so on. So, as a part of setting a research goal, they define the research goal and create a project charter which gives an idea about what they want to do in the total data science process. The second step is retrieving the data. Of course, we all know that in order to conduct a data science process, we need to have data. So this second step is obtaining data from various sources according to our requirements. So there are two types of data, which is internal data and external data. Internal data is the already available data which is present within the organization. But external data refers to the data which is obtained from external resources. Okay, so basically external data is used from other organizations, like for example if you're gonna collect information from outside organizations or from organizations like who, if they want to create a health based data science process, or commercial means then they'll be going and collecting data from various supermarkets, etc. So all these constitute the external data sources. Okay, so the data obtained from these external sources are known as the external data. By using external data, we need to have the permission to use these data for our data science process. But if you're using the internal data, then we don't need any such kind of formalities because it's our data, right? So next, let's go to the third step. The third step is data preparation. Once you have got data, now we need to check for the errors in the data. There are lots of chances that there are some errors. For example, one person would have bought a particular item from, say for example, Amazon, and the same person would have bought it from Walmart. So both the data have been captured, right? So what would have happened? We'll be having redundancy of the data. That is, in the count of data, how many people likes a particular product, the same person would have been added in both the data sources. And while obtaining data from both the sources, there will be a redundancy. So our purpose in this particular step is to remove these data, remove these redundancies, errors, physically impossible values, missing values, outliers, etc. All these constitute the data cleansing process. Now, what is data cleansing? It is removing all the unwanted data from the raw data. Okay, so what we got here is the raw data. After cleansing, we get a good data which is apt for our data modeling and so on. Okay, so this is the data cleansing. Then we have data transformation. This constitutes various data related operations like aggregating data, which means we are collecting data and aggregating it, or extrapolating data. What is extrapolating? We create our own values based on the already available data. That is extrapolating. Okay, by using certain functions, we create our own values of data. Just imagine that I'm having just 100 data points. Okay, now I want actually, say for example, let's have 150 data. Now I have already 100 with me. So the 50 data values, if I want, I can extrapolate it. Okay, so that is how extrapolation works. Normally we don't extrapolate for such a large quantity when we are very much concerned about the precision, but still extrapolating data means this. Okay, then we derive measures to create a good transform data. Then we create dummy values. Okay, and then we also reduce the number of variables. For example, let's just have that my concern is about how much people have bought the product. Okay, let's say the product name is ABC. Now I'm not concerned about at what time they purchase the product, because all I want is, do they purchase the product or how much quantity have they purchased the product. That's what is important. So all the unwanted variables like when they purchased, Okay, what is their credit card number? All this unwanted data will be removed. So this is reducing the number of variables which is required for the model. Next, from various sources we have collected so many data, no? So all these data are combined, merged, okay, to get a one particular reliable data set. Now for this we use various data operators also, and we create views in which we have only the table values which is important for the data process. So that's what we call as the view. Okay, so for a particular data process, what is the data required, that alone will be taken. For example, if I want to conduct research only on the people who are buying this particular product in XYZ region, then only those what's that, those purchases which have taken place under the XYZ region will only be considered. So that is what we call here by creating views. Okay, the next fourth step is data exploration. Once you have created views and we've got only the required data, now what we do is we explore the data. This is where we say that we just explore it. We identify all the hidden patterns, relationships between each variables. And in most of the data science process, even according to my experience, there are lots of chances that we get unpredictable relationships. Like for example, by just seeing, we couldn't know that they have relationship, but they do have relationship when we are plotting them in the graph. We can say not necessarily linear relationship, but there are lots of relationship. What is relationship? Relationship means that if I know one particular value, then I can predict the other value. That is relationship. Okay, so if I know just a person is belonging to this particular age group, then I should be able to predict how many amount of the product they'll be buying. So that is what we say relationship between two variables. So here we have two variables. What are the two variables? The age factor and the quantity they buy. So like this only we actually plot relationship. So we are plotting this using simple graph, combined graphs. Okay, so simple graphs just have simple two variables. Combined graph is a complex representation. Okay, and link and brush method and non-graphical techniques also. So this link and brush method and all is used for commercial purposes. Non-graphical techniques include statistical methods like finding the mode, median, distribution, etc. Then we have data modeling. This is where we use models. Okay, here we have statistical models like ARIMA, things like that, and then we have even what's that, neural network based models. Okay, so we use lots of neural networks to plot the data model. So this is data modeling. Then we have presentation and automation. Here we present what we have identified. This is the final step, and here we present what we have identified, and then we present it to a large amount of people. Okay, so why we do this? We do this so that even non-technical persons should be able to understand what we have inferred. So this is basically done to show to a larger masses what you have gathered, concluded, inferred from the data analysis. So this is very similar to a science project. Okay, whatever you have inferred from this, you should be able to explain it to a wider mass. So that is the final step. And once this is done, for the streaming data, that is even for the future data, you should be able to use this particular model itself to automate, to identify the relationship. So that is where we have this automating data analysis. Okay, so in real life we have lots of outliers which we need to consider for automating this data analysis. Thanks for watching.